This is for Year 12 methods. We're just going to look at a question from one of the practice SACs. Okay, so given a g of x happens to have a parameter, so it's a hyperbola parameter, I want to find the inverse. Okay, so a good way to get the inverse is just define the function first. So I'm just going to type in the function, -1 x plus 1 plus a. So you get a from the variable menu. Oops, g, a. And then all I do is interactive define as f of x, okay? If you have f of x, define as another letter, so you can do g of x, okay? But remember, when you're choosing another letter, it has to be lowercase, so it has to be from the ABC menu. Okay, to get the inverse, you swap the x and the y. So there is a function way of doing this. Swap x with y and x or y of x. So if I go maths free, there's an f there I can use. I want f of y equaling x. So that swaps the x and the y. And you solve for y. Interactive, advanced, solve for y. Okay, and you'll notice that this isn't in proper fraction notation, so you have to, I'll just drag and drop and then just go transformation, fraction, prop frac, okay? So g minus 1 of x equals to minus 1 over x minus a minus 1. Okay, so I've got that. So we want to find the number of intersections between g and its inverse given different a values. Okay, so the easiest way to do this is to use a slider, because we're not asking for like what the intersections are, we're just wanting the how many intersections there are. So slider will be probably the easier way instead of like subbing in each of the values separately. They'll take forever. So what I'll suggest you do is click the graph button, go y equals to, type in the two equations, so the inverse and the original, x plus 1 plus a, oops, wrong menu, plus variable a. Okay, that's the original equation. And we've got the other equation, so minus 1, x minus a. So again, variable menu, minus 1. Okay, tick tick. And when you're graphing with a parameter, make sure you use the parameter graph, okay? Now, it defaults by -10 to 10, which is perfect. We've got all the numbers we need. Okay, so I start at -4. What happens? Oops. So -4. Now, note your calculator will be a lot slower than what I'm doing on the screen. So just bear that in mind that you got to actually understand what's going on quite quickly, rather than because you don't have time to scroll through the different values again and again. Okay, I can do it on the computer because it's quicker, but in the exam situation, you've got to use your time judiciously. Okay, so -4, you have two intersections. -3, one section. Okay, you can verify this if you're not sure. You can verify it. Just go analysis gsolve to see that's only one section. -2, known sections. -1, that's interesting. It's the same line, so infinite amount of intersections. 0, known sections. 1 section. 2, 2. Okay, and if we keep going, we can see it keeps going to 2. Now, if I go the other way, like if I go below -4, so -5, -6, etc., if I see what's going on, again, it's going to go 2, 2, 2, 2, 2 in the other direction as well. Okay, so if we think about it, when do we have known sections? So for none, it says find the values of a, which gives you the domain of a, which gives you known section points. So known section points is when, so you have one section point there, right? So it'll be between when a equals -3. -2 still has known section points. -1, it has infinite. And then 0 has known section points. 1, it kisses again. Okay, so what's going on is that for known intersection points, it'll be between needy free, so needy free, and 1. Okay, because between needy free at 3 and 1, it intersects at once. So it'll be between A would be an element of needy free to 1, but there is a problem at negative 1 because it intersects infinitely. So it'll be all that except negative 1. Okay, so that's when there's no solutions. Okay, when is there one solution? So one solution, there's only 2 values that give you one solution. It's when A equals negative 3 and 1. So A is element. Now we're going to do the fancy brackets, the set brackets, negative 3 and 1. Okay, and then 2 solutions will be from 2 onwards, and from and before negative 4 or below. So A will be element of negative infinity to negative 4 union 2 to infinity. Okay, so those are your three scenarios. Okay, verify your solution in E by setting g of x equals 0. Okay, so we can do that. So go to main menu. I used f of x. Okay, alright, so I want f of x equaling x. Okay, remember the intersection between the inverse and its original is the same as in either one of the functions intersect with y minus x. Okay, that's what we're doing. So interactive and solve for A. Okay. Oh, not A, sorry, X. Okay, so I'm not expecting no solution, so there might be a problem. So whenever you use the parameter stuff in the menu, it sets the A value to be a certain value, okay? So you got to check whether A has a value to it now, and you can see it has a value of negative 1. So you do have to clear the variable. So it's very important that you realize this, because if I don't clear the variable, it's taking the A values as a negative 1. That's why you have no solution. So let's do this again, and you'll see that I have an A value now. So A would be the plus minus version of that fraction. So if I let, was it g of x? Yeah, g of x equals to x, then x equals to A plus or minus A squared plus 2A minus 3 minus 1 over 2. Okay, now what we're interested in is the discriminant, because that's the limiting factor which gives us the solution. So we can verify the solutions. Okay, so if I use this, if I drag and drop this part down here, okay, and maybe change that to x's, okay, just so that it's easier to graph, we can see, so I'll graph the discriminant. This is what's going on. So if I graph the discriminant, if I graph the discriminant, okay, you can do it algebraically as well. I'll show you how to do that algebraically. You graph the discriminant. Where are the intercepts? Analysis G solve intersect root negative 3 and 1. Okay, and that's the discriminant versus your A. Now, one solution is when A is equals 0. So therefore, not A equals 0, when discriminant equals 0. So one solution, A equals negative 3 and 1. Two solutions is when it's positive. So A will be element of negative infinity to negative 3, union 1 to infinity, and then no solution is when it's below. Okay, so when it's below. So A would be an element of, so when is it below? It will be between -3 and 1, not including 1. Now, where did you might be wondering, like, where's the -1 come from? Well, the -1 comes from the turning point. So if you get the turning point, analysis G solve minimum, you can see that at -1, that's where the turning point is. So that's where the excluding -1 comes from. Okay, so we've verified. It's only one marker, but it's showing you that this can be done algebraically as well. Okay, now if you don't want to do this graphically, like you don't want to graph it and all that, you can solve these inequalities on the CAS. Okay, so like as in on the main screen. So if I want two solutions, I go that's greater than 0, discriminant's greater than 0, solve for x. Analysis G solve x. Okay, so it gives you the correct domain for that, or equaling x to one solution, or no solutions. Okay, but if you do it this way, you will miss the -1 because it happens to be where the turning point is. Okay, G is doing something similar. I'm going to define this. K and its inverse. Okay, find where that happens to have none, 1, and 2 intersection points. So again, I'm just going to use the discriminant method instead of using parameter. So I'll just go -1, x plus b, x plus b plus 3 equaling x. Okay, I'm just going to solve for x. Okay, so I'm just checking what might simplify this. Okay, that will simplify. So if I let kx equal x, then I've got x equaling, what was it? Minus b squared plus 6b plus 5 minus 3 over 2, or minus b plus square root of b squared plus 6b plus 5 minus 3, minus 3 over 2. Make sure your fraction extends beyond. Okay, over 2. And then I'm interested in the discriminant. So you've got b squared plus 6b plus 5. So we want none. So no. So discriminant equals that. Now I'm going to graph this very quickly. Now you can't graph it with b. You just have to change these to x's to graph it. So remember, if you graph it, you get. Okay, so I'm just going to delete the original graph, clear all, and then graph this. Okay, analysis, G solve roots, -5 and 1, -5, -1. So we've got -5, -1. So for one solution, b has to be equal to, or b is an element of set bracket -5, -1. Two solutions. B is an element of between -infinity to -5, union and including -5, union, oh no, not including -5, and then 1, -1 to infinity. Did I include the other one? I think I made a mistake here. Sorry, that shouldn't include. Okay. Yeah, and then no solutions. Two solutions, no solutions. Okay, no solutions. It'll be B is an element of. Now, we got to get the turning point because that's when you get infinite solutions. Minimum happens to be -3. So it'll be between -5 and -1, excluding -3. Okay. So again, if you really wanted to, you can solve this using the equation itself. Okay, so you can go greater than 0, and you get your domain. So analysis gsolve event solve for x, you get your domain. But remember, you're going to miss the -3 part if you don't actually graph the discriminant or draw a discriminant. Okay, because this is the discriminant O versus B. Okay, so hopefully that explains how you approach this type of question.